Dr. Theoharides. So I'm so honored to be talking with you today and to have this opportunity to talk about something that applies to everyone, and that is inflammation. So we're going to be talking about brain inflammation, mast cells, the impact of environmental toxins, flavonoids, and how this relates to autism. But first, I want to talk about you and your background because you are known as the worldwide expert on mast cells. Is that right?
That is correct. Well, first of all, let me thank you. You're wonderful. What you're doing is absolutely necessary, and it's a delight to be talking to you.
Thank you. I appreciate
So,
that.
just quickly about myself. I was born in Thessaloniki, Greece. I came to Yale University with a scholarship as an undergraduate, and I ended up getting 6 degrees from Yale. So I liked
Oh
it,
my gosh.
I guess.
Wow.
So then I moved to Boston. I did training in internal medicine, and I started the Department of Pharmacology at Tufts University, which I helped run for a number of years. And I got hooked on this unique immune cell, the Mast cell, M-A-S-T, about which we will talk later. And that led me to neuroinflammation, and that led me to, well, maybe I should retire from Tufts after 35 years, and came to Florida, where a good colleague and friend, Dr. Nancy Klimas, has an Institute of Neuroimmune Medicine, which allowed us basically to think outside the box and use integrative approaches, which you know very well, of course.
I love
And,
that.
and neuroinflammation, as we will talk later, seems to be involved in every pretty much condition you can imagine. More
Mhm.
so in some of the conditions we will be talking about, and of course, autism. And we reported on inflammation in the brain of autistic children almost 15 years ago. And my God, no one believed us. I mean, I remember giving lectures and having people from NIH say, "What on earth are you talking about?" And
Wow.
since then, as we will talk, there are many epidemiological studies showing exactly that. So
That's just fascinating.
that's,
And you've been doing research for 42 years?
oh my God. Well, we've been doing research on the mast cell for 40 years,
Wow.
research on neuroinflammation for more than 30 years. One of the key papers that we published was published in 1990, and I called mast cell the immune gate to the brain. And as we will discuss, that's exactly what it does, among other things. And
Wow.
we just unfortunately still in medical school teach only about allergies.
Yeah.
Uh, I'll give you an example. It's a horrible example of how little two colleagues know. But a few months ago, I got an urgent phone call from a physician who was in Florida vacationing, whose wife had an episode that clearly involved activation of mast cells. Let us call it severe allergy. So they
Right.
went to a local emergency room, and the physician husband said, my wife has mast cell activation disorder. And the answer from the attending physician at the ER was, "What's wrong with your breasts?" Because the word masto comes like
Oh,
mastocytosis. So you can imagine how absolutely ignorant colleagues are even to this day, let
that's
alone try to connect it to things like autism, for instance.
absolutely. And that has to do with the disconnect with our education, right?
Yeah,
With what's
yeah,
being taught.
yeah. We just don't teach it. And we should, but that will take monumental efforts to do, unfortunately, because mast cells, and I'm jumping ahead of ourselves, have been associated with a number of diseases that otherwise are not necessarily believable by the medical profession, such as chronic fatigue syndrome, such as
Hmm.
fibromyalgia, such as interstitial cystitis. So
Yep.
in medicine, unfortunately, if we don't understand something, either we don't believe it exists or we call it idiopathic, meaning, again, we have no idea what it is.
Right. And it's just looking at the mechanisms. We need to look further at the mechanisms to
Correct.
figure that out. So yeah, let's talk
Correct.
more about that. I do want to touch base on your publication because you have 493 publications, right?
It's
Around
now,
there?
now it's 500.
Oh my gosh,
So
500 publications.
I've
Wow.
got colleagues who have many more publications, believe me. But I think it's a good number.
That's a very, very good number. That's incredible to me to have that many publications. And but it's wonderful because you've laid the foundation for people like myself to learn from those publications. So that's really appreciated.
What you said is very kind and very true, but also very sad in the sense that you read them, and yet many colleagues don't read them. So
Right.
I've been in meetings with pediatric neurologists and child psychiatrists, and everything is anything but quote unquote biomedical. It's as if our body doesn't have some underpinnings that lead to whatever symptoms we see. So we used to say, if we didn't believe something, oh, it's psychosomatic. Okay, well, psychosomatic didn't sound right, so now they call it functional. Same thing, we don't know what it is, but obviously something is happening. People don't lie; we see the symptoms. So it's up to us to try to find out why they're there, rather than just bruja-hiding it. So thank you for reading, and thank you for making every effort to get it done.
Absolutely. I mean, I haven't read all 500 of them. I have a lot of work to do, but I think part of that too is that when we talk about scientific literature, it's very complex. It's hard to read and interpret and synthesize that information, especially if you don't have a medical background. So do you think that's kind of part of the issue too, is it with it being
it's even worse. 3 issues. Number one, as we all know, if you quote unquote Google something, you'll find anything you want. Whether it's true or not, it's anybody's guess. Number two, when I was at Yale, there were about 100 publications or so that were in journals that we all consider very significant. Or putting it differently, there were journals that we believed when something was published. So we tend to call them high impact factor. And that holds a lot of water. But to give you an example, you take Nature, you take Science, you take New England Journal of Medicine. We always tended to believe them much more than other publications. Now, there are about over 1,000 journals publishing. Some of them beg you to publish. You give them $3,000 and they publish pretty much anything you want. And it is impossible for the public to really know the difference because they don't know about impact factors. They don't know about details, etc. And a very significant paper was published 2 weeks ago where they reported something that I used to include in a graduate course I taught up in Boston. About 40% of the papers published are fraudulent. Not just published in junky journals. They're just outright faulted,
all this falsified information that the public is reading.
So I used to teach a course called Advances and Failures in Drug Discovery. So I will choose about 10 topics over as many years, and we'll discuss about a topic that absolutely turned the world on their head about how important it was. The Wall Street was, drooling over it, etc., and they failed. And one of the reasons why they failed was, and this has been published in the Proceedings of National Academy of Science, etc., that companies could not reproduce basic science that was actually published in good journals, because you've got to start somewhere. So we're wasting money, we're wasting time, we're confusing the public, etc. So obviously, the consumer out there, can't really look for every publication and the impact factor and all of that. All I'm saying is we have to be very careful, especially about publications that say, oh my God. So I was in a conference, for instance, in Italy about 10 years ago, and an invited speaker was talking about autism. And he said from the podium, we're going to get the Nobel Prize because we know how to fix autism. And, anybody who gives you that statement outright has got to be wrong.
Right, so, red flag.
Not only that, but when they presented what was their magic cure, and there's no cure really, they were using luteolin that we've had actually in the Algonaut products for years. So they can say whatever they want, and depending how they say it, and depending how quote unquote powers to be put it out in the media, it becomes like the dogma. And we will talk about, I don't want to use the word treatment because I used to teach another course that was called Treatments, Therapies, and Cures. And we use the words interchangeably and then don't mean that at all. Right. I mean, as I tell students, if you've got pharyngitis, which is mostly strep, and I give you penicillin, well, that's really a cure. But short of that, we really don't have cures for most of the diseases. And therefore, I try to avoid the words treatment and therapy when I don't know what I'm dealing with. And I say, and I use the word intervention, which is kind of broader and allows us to talk about other things.
No, I like that. I like that. That's something, a really big point to bring up, is that difference there.
Yeah. So anyhow, I went on a tangle, but
no, I love that. Thank you for that information. That was wonderful. Sure. And let's talk about, so most people don't know what mast cells or microglia are. So can you explain those in simple terms?
Sure. So we have the immune system, and the immune system has both what we call humoral component, meaning antibodies, and cellular component. And there are many different types of cells. But we usually talk about the cells that circulate in the blood. So we talk about, leukocytes, for instance, or the polymorphic nucleocytes, or T cells. The mast cells are unique immune cells. They come from the bone marrow, most of them, just like other cells are, like red blood cells and platelets and what have you. But they are in the circulation only as precursor cells. Then they move into the tissues, and depending on the type of tissue and the microenvironment, they change basically their ability to respond to whatever triggers there might be. So I consider the mast cells the canary in the mine, because they're found in all tissues exposed to the outside world, eyes, nose, mouth, lungs, skin, gut, but they line up the blood vessels everywhere in the body. And what they do amazingly is, as you imagine, a vessel is made up of two endothelial cells. Mm-hmm. And through the gaps where the endothelial cells come together, the mast cells, which are on the tissue, this is the lumen, send actually philopodia through the gap, and they sense what is happening inside the blood. And therefore, they can sense what's happening inside and outside the body. And they're the first cells to be activated. And then depending on the trigger, they orchestrate a response to try to contain basically that problem. So think, the mast cell is like a soccer ball filled with about 1,000 ping pong balls, each ping pong ball having about 50 marbles inside. And when they're activated, let's say, God forbid, someone is in an anaphylactic reaction because they got stung by a wasp, then they release the contents like a hand grenade exploding immediately, within a minute. But then over a period of 12 hours, they can synthesize and release another 300 molecules. So think, the muscle can make 350 molecules, and we literally deal with just one of them, histamine, and we give antihistamines. So we're sat ignorant, basically, about what the mast cells can do. And most importantly, from my point of view, they line up the meninges, the membranes that cover the brain. They literally hug the protective blood-brain barrier that protects our brain from anything to come in. And in addition, they're found primarily in the area of the brain that is called thalamus, hypothalamus, and amygdala, that regulate behavior and how the body responds, which we call homeostasis. And the brain doesn't get allergic reactions. Yet the only thing we teach in medical school is how important mast cells for allergic reactions, which they are. But that's the tip of the iceberg, basically, as to what they do. And that's what was fascinating from the beginning, because my doctoral thesis at Yale, in addition to the medical degree from Yale, was to find a secretory cell and find out how it secretes. And I was fascinated by the mast cell because it's got 1,000 granules and so many mediators to be released.
Yeah, it is. It's
so I'll tap myself on the shoulder. We were the first to show two things. One, that the mast cell under circumstances can release the content of each one single individual granule. And we published that in the journal Science when I was a graduate student. And the other, it can secrete actually single molecules, whether they're from the granules or outside, without the mast cell degranulating or exploding. And the second part is very important, because if you're truly allergic to something, then the mast cell will release most everything. So we call it degranulation. But if the mast cell is triggered by viruses, by bacteria, by stress, by heat, it does not release histamine. It releases only pro-inflammatory molecules. And that's the part that we've been studying, and that's the part that most everybody else is missing because they think it's only histamine. And of course, a unique enzyme that is found in the mast cells called tryptase. We can return to this later.
So when those mast cells are activated, they're releasing all these pro-inflammatory cytokines, having those downstream inflammatory effects. But not from mast cells.
Correct. And I did not reply as of yet to your other part of the question, the microglia. Yes. So the blood-brain barrier prevents any immune cell that is in the blood from getting into the brain. If, let's say, blood-borne leukocytes or T cells get into the brain, they will recognize the myelin that covers the nerves as foreign, will attack it. That's how you get multiple sclerosis. Okay? So the brain has microglia. Microglia are the innate defenders of the brain. And if you allow me, I usually describe it as the microglia are actually spiders, and they make spider webs. And on the spider webs, the neurons crawl and make their connections. Now, if the microglia is in danger, two bad things will happen. Number one, they'll stop making the spider web, so there's not going to be any scaffolding anymore for connections. And they multiply like crazy and attack the quote-unquote invader, and they result in a localized inflammation. So in certain cases, depending where the blood-brain barrier opens up, and depending what the trigger is, there will be a focal inflammation, not a generalized like encephalitis, for instance.
So you're having inflammation in a certain area of the brain, and then that's when that blood-brain barrier permeability opens up, and that's when more substances can enter the brain. So you get toxins and other things that have an open gate, and then that leads to more mast cell activation, right?
It becomes a cyclic reaction that you cannot stop.
Oh my gosh. So, and then is that the same with the epithelial barrier?
Well, you're very correct. So if you refer by epithelial barrier to the gut-blood barrier, if that's what you're referring to, is that what you're saying? Okay. Yes. So there it's exactly the same, except that you don't have the same. So in the brain, you've got endothelial cells, then you've got pericytes. In the gut, it's a little different, but the mast cells are right there. And one thing that we might discuss later is, many people think, might have gluten enteropathy, for instance. Well, you don't have to have full-blown celiac disease. In celiac disease, the villi of the gut are flattened, and you really have a lot of problems. However, you can start having disrupted gut-blood barrier, and we can measure that by measuring in the blood molecules such as zonulin or gliadin or transglutaminase. Those are going up long before you flatten the villi. And that's something that we should be measuring because that's an index of what might be going on. Now, the good thing is that if in fact this is happening in the gut, it's easier to track than tracking it in the brain. Because in the gut, we can do a stool analysis for three things. Total histamine, that will come from the mast cells, eosinophilic cationic protein, which comes from eosinophils that usually go together with mast cells, but they trigger the mast cells, and a molecule called calprotectin that is an index of inflammation in the gut, because we cannot do this in the brain. So at least there we can do that part. Now in the brain, the only way to look at microglia activation is to do what is called a SPECT scan, or single positron emission computed tomography, which shows basically the microglia lighting up. Of course, if they light up, that doesn't mean to say it's autism. It can be any other neurologic condition. But if there's no other neurologic conditions, and they light up, then clearly it's indicative of something like this happening.
Some kind of inflammation going on.
Right.
Okay. So can you walk us through when there is an inflammatory trigger, like let's say mold, pesticides, heavy metals, parasites, viruses, any of these things that could potentially activate that cascade, what does that kind of look like? So let's say we get exposed to a toxin.
Sure.
And what does it trigger?
Sure. So there are at least two things that can happen immediately. One is that the toxin or the component of the toxin can stimulate either the mast cells directly or the microglia or both. So we published, for instance, that ochratoxin A, which is a common mycotoxin that is liberated by certain species of fungi and is volatile, can stick to carpets, clothes, whatever. It can stimulate, as I said, the muscles or microglia to release pro-inflammatory molecules. That's pretty much immediate.
Okay.
However, the body then can make immunoglobulin E antibodies against the toxins or the component thereof, and those can trigger a typical allergic reaction when someone is re-exposed. So the first exposure, immunoglobulin is not involved. It might be involved later on.
Okay.
That's why if we suspect mycotoxins, it's important to measure them in the urine to know if they're there, someone is still being exposed, and measure Ig antibodies against the mycotoxin, which will give us an indication whether it's been going on for a long period of time.
Okay.
Now, toxins can also do direct damage to neurons. So many colleagues have published that toxins, including mycotoxins, can trigger the neurons, both in the brain and in the periphery.
Is that through oxidative stress, typically?
We'll talk about stress in a second, but it can be direct stimulus. And to give you an example, a paper was published, a wonderful paper in Nature about 2 years ago, where they showed definitively that just histamine being released from mast cells in the gut sensitizes the sensory nerve endings, and it presents as colicky pain, abdominal pain. And, many of the children have colicky pain, and we usually don't know what to do with them. Well, over the years, we've come to realize that they might be actually either sensitive or truly allergic to milk products, whether it's cow milk or the mother's milk for that matter. We didn't know that. And now, according to that paper, it said that the growing fetus in the mother, if it is exposed to the same allergens that the mother is, if she has like a hay fever or eczema, whatever, it will affect the mast cells in the fetus.
Wow.
We always thought that the baby has to be born, and usually it takes a couple of years for the mast cells to mature. That's why many allergists do not do allergy testing in children, younger than 3. Well, as it turns out, that's a fallacy. The mast cells are ready to fire, basically, while in the womb. To make things worse, the protective blood-brain barrier does not start maturing until the beginning of the second trimester. So if the fetus is exposed to all these things before that, then obviously the development of the brain is going to be affected as well.
So that first trimester,
that's not most important, period. I mean, we've known that it's important because of the development of the organs, etc. But now it's becoming more important because anything the mother's exposed to will go through the placenta, will affect basically the mast cells and the neurons, basically in the brain. So that's the other thing that the toxins do.
So that's any toxin. So toxins in our food, in our air, in our water, when the mother is being exposed to them, they're having that direct effect or can have that direct effect?
They can. It's just that it has not been studied sufficiently. Wow. And unfortunately, we keep on adding chemicals to our environment, and then 100 years later, we realize what the hell, excuse the expression, doing.
Right.
To give you an example, which is close to what we're discussing, there's a small, what we call fatty acid, propionic acid. Propionic acid is made by bacteria in the gut, normally. Okay? However, if the gut-blood barrier and the blood-brain barrier opens up and propionic acid gets into the brain, forget it. There was a Canadian scientist that published numerous papers where he injected propionic acid intraventricularly, direct in the brain, in mice, and the mice developed what appeared to be like an autistic trait. Obviously you can't call it autism, but they would not play with each other, they would not rub their noses, they chased their tail, etc. And why am I stressing this? Because propionic acid is one of the most common preservatives in drugs, in supplements, in cosmetics, and no one is telling us that.
Wow.
This is what is scary, not so much that they're using certain things. They just don't tell anybody. They usually say inactive ingredients and then don't list all the inactive ingredients.
Oh, yeah. And that's something I learned the difficult way, just as a pharmacist, is, even vaccines, I wasn't taught about the inactive ingredients. And now when I looked into it and find all these things and how that could potentially have those effects on a vulnerable infant, it just was so eye-opening. And it's mainly why I'm here, wanting to dive into all of this and the potential dangers that we're putting our children at risk at, because we don't know of these things.
I don't know. I mean, the FDA or the Federal Trade Commission, FTC, should be looking at the inactive ingredients because there's a lot of published information about them, as well as non-active ingredients. For instance, we'll talk about some of the products that the company Algonaut makes. Algonaut checks for glyphosate presence. Hardly anybody does it. And as you know, glyphosate is found in Roundup. It's the most common herbicide. And yet an experiment was published almost 9 years ago by MIT where they laced basically a beehive with glyphosate. Within a few hours, the bees could not find their place anymore. They were so disruptive to the nervous system. And yet, we allow it to be promoted, not it's only present, they promote it.
I'm right there with you. There are so many things, so many talks, and I'm hoping we're moving in that direction and those things are going to be happening, but there's just a list of toxins that shouldn't be allowed in our food or water. It
was BPA, bisphenol A for plastics. Mm-hmm. Now we talk about microplastics. Yep. It appears like every time we drink something, we eat something out of a plastic container, we consume some microparticles that we were never aware of.
Yep. Yeah. So, well, and I've done a lot of research on aluminum, and aluminum's in all our cookware and our bakeware, and it's everywhere. And how do you limit that exposure to decrease that risk? So it's something that hopefully, all Americans are starting to wake up to and realize that these toxins are real and they have real effects.
Absolutely.
So I think this is super important that you're talking about that and mechanistically how it happens, how that inflammation happens so that we all can understand. So, and have you looked at specific toxins?
Worst part is that many of these toxins work synergistically. So, various levels are developed by, European or American, whatever, societies or groups. But let's say that something is supposed to be less than X. Mm-hmm. And it might be 10 times less than X. But if you have 20 of those less than 10X, together, they become more than 10X. Absolutely. That's what we don't understand. Right. It's not just the individual one that has to be within a certain low limit. It's what happens when you have too many of them. Yep. That's where the body gives up. They're trying to deal with them, and they cannot deal with them. And as we might discuss later, we also have liver enzymes that are detoxifying. But we know that many individuals have mutations. We call them polymorphisms, so that the enzymes don't work very well. So we call them either fast metabolizers, as you know in clinical pharmacology, or slow metabolizers. So if someone is slow metabolizer, even the normal, quote unquote, normal level of a toxin might still be too much for them because they cannot detoxify.
Yeah, it's so personalized because of everyone's genetics.
We have to do personalized medicine.
Absolutely.
That doesn't make sense.
Yeah, I completely agree. And then when we're talking about detoxification, for instance, we have a max level then that our pathways, kind of max out. So then those toxins don't have a way to be eliminated, right? They just build up.
Correct.
So, and if you have those enzymes that make it more difficult, you're more likely to even have more toxins build up, right?
So you were about to ask, and I apologize, I interrupted you. So we did publish a paper many years ago with my graduate students that mercury activates, for instance, the mast cells, and it activates microglia. So there you go. And, we've known, unfortunately, medicine for many years in the 18th century, whatever. Mercury was used to treat various diseases. And it took us a while to realize that it was actually toxic to the brain. Mm-hmm. And you might recall, I'm sure you know the story, but in Alice in Wonderland, we had the Mad Hatter. And he was using mercury basically to clean the felt from the heads. And that's why he was brain toxic and he was mad.
Oh my God.
Many times, all of these, pearls, I call them, are there in the literature at a time that we didn't quite understand why they were there.
Yeah.
But,
it's a good point. I feel like we have the answers. They're in the literature and it's just putting them together and piecing all that together.
Correct. Sometimes, unfortunately, we might go overboard, and I'm not talking about mercury. You might say, well, this causes all the problems in the world. But once we go that route, then no one believes it. So we've got to be careful and document it well and publish it. That's why I'm publishing a lot, because I feel that if I publish it, first of all, I'm under the scrutiny of quote unquote peer review, other people will review it. And then it's out there for other people to read. It's not anecdotal anymore.
Yeah.
And hopefully, other colleagues will do the same. It's a pain in the neck to publish.
Oh, yeah. That's a lot of work.
My students used to argue with me because I might go through 30 drafts before we publish something. But I had two wonderful mentors when I was doing my doctorate degree at Yale. One was William Douglas. He was a member of the Royal Academy in London. And he used to be a surgeon basically in the Middle East. He was very strict. So he used to have actually the dictionary of the English language. And we will sit down to write a paper and we will look at every word. He says, if you can use one word, don't use 5 words to say the same thing. Just be precise, And then I had the other mentor, Paul Greengard, who got the Nobel Prize in physiology and medicine a few years after I graduated, who was actually a prolific researcher. So there were two extremes, basically, from different points of view. So Douglas would watch the language. Greengard was actually after the science. He said, let's move on, etc.
Yeah.
So I had the benefit of getting kind of two sides of how to write a paper.
Yes, well, it definitely benefited you, I'd say. You're definitely focusing on the science and then publishing and getting it out there, which is...
I remember the first time I convinced Bill Douglas to send a paper to Science. He said, I've never published in Science, we'll never publish anything in Science. So I stood on my head and I kind of begged him, and we sent something for publication. And I remember the envelope came back and he would have it on his desk for weeks. He didn't want to open it because he was afraid it was actually a rejection. It was a rejection. And as it turned out, it was an acceptance. So I had this dubious honor as a graduate student. I had 2 papers published in Science, 2 papers published in Nature.
Oh my God.
Which at that time especially was, quite phenomenal. Anyhow.
That is phenomenal. That's fantastic.
Thank you.
And let's get back to, I want to talk about your research on autism and inflammation, because you've actually published studies specifically on autism. I think you have like 40 studies, is that right?
That is correct. We've got one more coming, actually.
Oh my gosh, well, I can't wait to read that.
So we took the following approach, basically. And I was a novice, basically, on autism. The way I got into it is, I am, as I was, on the scientific advisory board of a group called the Mastocytosis Society. Now it's called the Mast Cell Disease Society. So it's a group of patients, basically, and they have an advisory board of about 40 physician scientists. And, many times when there are actually either annual conferences or biannual conferences, the first day used to be hard science, and the second day would be some of the presenters of the first day will kind of present the same thing, but in lay terms for the families. So it was one such conference where I was absolutely stunned how many families came with children that were absolutely obvious to me that were on the spectrum. Mm-hmm. So we did a small epidemiological study that we published, about 60 years ago, where we showed so it was actually a questionnaire that was given out to the members, and then came back, how many of the mothers of the children had actually a diagnosis of mastocytosis. And it was actually 1 in 10, while at that time, the chance of having an autism was 1 in 150. Mm-hmm. Now, of course, it's 1 in 31. But considering the fact that mastocytosis is extremely rare, and the fact that autism at that time was fairly rare, usually the statisticians, if they want to see comorbidities, they multiply the ratio, 1 over, it was 0.003 for mastocytosis times 150. The chances of children having both was totally out of the ordinary. So we kind of said, there's got to be something going on here. That's how I got involved. And then we started looking at other conditions where the mast cells are involved, like eczema, and that became even more common. And since then, there have been about 7, actually, epidemiological studies published in very good journals, including, Translational Psychiatry, including the Journal of the American Medical Association, where they showed that eczema is the only statistically significant comorbidity with autism. That doesn't mean to say that everybody has eczema will have autism. But again, The connection was actually becoming even stronger. So then we said, well, how can we study that? So one possibility was to measure any molecules in the blood that we knew could trigger mast cells in the children with autism. So we looked at about 20 different, we call them neuropeptides. And as it turned out, only one, neurotensin, was actually high. And the second one was corticotropin releasing hormone, which is released under stress, CRH. And just to remind everybody, the CRH is released from the hypothalamus, stimulates the pituitary, that stimulates the adrenals, put out cortisol. Well, cortisol is supposed to be anti-inflammatory. I mean, we give cortisone for inflammation. So that didn't make sense. So then we started studying, along with a wonderful colleague who's at NIH now, he's in Greece, George Chrousos, whether there's a possibility that CRH is released outside the brain. And as it turns out, it's released in the skin, in the bladder, in the gut, and there it stimulates the mast cells, therefore it is pro-inflammatory. So basically you have a balance between cortisol being produced versus stimulation of the mast cells to put it sort of simply.
Wow.
And we showed that both in eczema and in autism, corticotropin releasing hormones were very high in the blood. And we published that. So with that, then we said, well, can we now grow mast cells in the laboratory? Can we grow microglial cells in the laboratory? And we do every day. And we stimulate them with neurotensin, and we stimulate with CRH, and what do you know? They release pro-inflammatory molecules, which now links to the inflammation. And having that as a very simplistic surrogate model, we pre-treated either the mast cells or microglia with various natural molecules. And that's how we came to the fact, as we might discuss later, that the natural molecule luteolin was actually the best inhibitor and could get actually into the brain. And the company Algoner was the first company to actually make luteolin available. But because it's absorbed less than 10% as a powder from the gut, they mix it up with olive pomace oil and created a liposomal form that increases absorption about 3 to 5 times.
Yes, let's talk about luteolin, because so that was a product you developed, and it, along with some other flavonoids, correct, that are in Neuroprotect. And then you actually, like you said, you use that liposomal formulation to help with the absorption to actually have the effect, because otherwise you don't get into your blood. It's just a very expensive supplement that you're pooping out, right? Yeah.
So why did we combine three? So as you said, the first product that was made was Neuroprotect with a K. And we decided to put three molecules in. One was the well-known flavonoid quercetin, which is known to be anti-allergic, anti-inflammatory. And that was going to do two, basically, effects. One was to calm down the mast cells, primarily, everywhere in the body, but it's also better destroyed or quicker destroyed by liver enzymes because of its structure. And what do I mean by that? All flavonoids are polyphenolic. And in fact, that's one of the things that I watch out with children and adults, either phenol intolerant, they're very hyperactive. And usually I ask them if you get hyperactive, you eat sugar, strawberries, berries, then I know they're likely to be phenol intolerant.
Okay.
Then we added, quercetin doesn't exist as quercetin in nature. It exists as quercetin glycoside, like a sugar attached to it, potassium sugar. So rutin is the quercetin glycoside. So when you give rutin, the gut enzymes cleave it and release quercetin in the gut. So to the children that have also GI problems, adding the rutin was very useful because I wanted to stay sort of in the body, take longer to be released. And then luteolin is the least phenolic of all, and therefore more likely to get into the brain. Plus, quercetin and rutin was also as decoys to use the liver enzyme to chew them up faster for luteolin to escape and get into the brain. So that was, the reason why it was done.
Yeah. So you're trying to tackling that inflammation in multiple different pathways.
Correct.
I know I looked at luteolin, and there's just numerous benefits with that I found, and multiple ways that multiple pathways that it helps the body with the inflammation. And one of those is that mTOR pathway by inhibiting or blocking mTOR. So as a pharmacist, it was confusing or is confusing to me because I think of sirolimus or everolimus, which are your mTOR inhibitor prescription meds used for transplant, can cause serious immune suppression. So can you kind of explain to me the difference there? Yeah.
I thought anybody would ask about that because it would have considered to be too esoteric, but obviously not for you. So for the listeners, when triggers come on the cells, whether it's mast cells or microglia, whatever, a whole set of reactions, of course, will be initiated before they release something. And so mTOR is a complex that eventually allows such process to take place. And it's called mTOR because it's mammalian target of rapamycin. So it was named after this molecule drug, rapamycin, which is very similar to the drugs you mentioned, except that rapamycin and some of the drugs you mentioned have quite serious side effects. Mm-hmm. So we can't really, give them at will, if you wish. So we published a paper in the Proceedings of the National Academy of Sciences about how luteolin and a new analog, methoxyluteolin, which is a little better, and I'll explain it later, can block the microglia. And then we published another paper in the Journal of Pharmacology and Experimental Therapeutics that the same thing happens in mast cells. So luteolin and methoxyluteolin, so methoxyluteolin has no phenol groups. Therefore, anybody can take it even with phenol intolerance. And it doesn't have color. That's why we put it into a skin lotion called Gentle Derm. So instead of using tacrolimus-like drugs for the skin, you can use Gentle Derm. But why I got excited? Because I have a paper about to be published. In fact, today they asked just a few more corrections, and it is comparing head-to-head rapamycin and luteolin and methoxyluteolin. Methoxyluteolin is much better than rapamycin in blocking mTOR. And it doesn't have any side effects whatsoever, except that it's not a drug. And physicians want to be prescribing drugs.
Oh my gosh. So is the reason that it's not causing the immune suppression like we see with sirolimus, is that because it's an indirect pathway and not like a direct?
You're absolutely right. We actually showed that it does block the phosphorylation of mTOR, and phosphorylation of mTOR is what creates the activation thereof. I don't know, that was one of the questions basically that I have to reply before they accept the paper, which I'll do as soon as we finish. If tacrolimus is not basically inhibiting mTOR as well, and let's say luteolin is much better, is tacrolimus doing anything else to explain its benefits in terms of immunosuppression, etc.? And I wouldn't be surprised if it does something more than mTOR. I mean, it was called mTOR because of rapamycin, but rapamycin and tacrolimus and other drugs could be doing other things as well. And don't get me wrong, the flavonoids like luteolin do other things, except that so far there hasn't been any adverse effect reported for luteolin. So,
mind-boggling to me. That's wild.
That doesn't mean to say that one individual might not tolerate it, but we're talking about adverse effects, something horrible happening. Nothing is reported. And in fact, as we may or may not have time to discuss, 3 papers have been published with neuroprotect that contains luteolin and quercetin in children with autism. And within 4 months, they gain basically the equivalent of 1.5 years of development using different scales of measuring, improvement.
That was giving neuroprotect?
Neuroprotect. So one study, I was not a co-author, so there wouldn't be any conflict of interest since I have developed it. The other 2, I was a co-author as well. And there were 3 points to make with it. One was that was used basically a small capsule for about 20 pounds weight. So you can't just give one capsule if a child is 90 pounds.
Right.
The second was, at that time, we didn't know about phenol intolerance. So about 15% of the children got a little hyper for a week or 2, and then it subsided. And that's why subsequently the company Algono that makes the supplements made the neuroprotect low phenol, where they reduce the amount of quercetin and rutin to make it more likely to be tolerated by the children that had actually phenol intolerance. The third part of the study is something that hardly anybody knows in the States, but as we all know, with a law from 1994, the FDA does not regulate supplements. However, if you want to export a supplement and you ask the FDA voluntarily and you fulfill the four things I will tell you in a second, they give you a document that says FDA and it's got a golden seal on it. It's renewable every 2 years. And all the Algonaut products have that. So number one, the company Algonaut has to be registered with the FDA, which it is. Okay. That means the FDA at time unannounced every 2 months, every 2 years comes, and not only they'll tell you, okay, let me see the formula or the product, they will ask you for the C of A, certificate of analysis, for every ingredient, active or inactive. Number two, you have to prove that the ingredients and the content were actually analyzed by an independent party, and Algonaut uses Eurofins in California. Number three, that the label lists the source, because many supplements, they will not say, they'll just say, it contains X. And the cheapest source, for instance, of course, it is peanut shells. But no one is telling you it's peanut shells. So, you're doomed if you're allergic to peanuts. Yeah. So the source has to be shown. And lastly, one study, even though it might be one small pilot study. In other words, it was given to humans and there was no major side effect, etc. Mm-hmm. So all the Algonaut products have a certificate of free sale.
And I would say that's rare to find with supplements. And probably one of the more confusing things as a consumer is because there's so many supplements that it's just overwhelming. And I haven't seen that certificate on many supplements that I've looked at.
And the FDA many years ago, I don't know, 8, 10 years ago, published a paper where they randomly chose some supplements. Algonaut was not enclosed in this. And they sent them for analysis. 65% of them had zero what they claimed on their label, zero.
Okay? Oh my gosh.
So not only basically they're misleading the public, but they're doing damage because whatever ingredients they have as fillers are likely to be having their own adverse effect.
Yeah, that's wild.
I'll give you an example. I was at a conference about autism, 3 years ago, and there was a company that was selling basically transdermals for all kinds of diseases. So they had a transdermal for allergies. And I went over to see what it contained. And it had luteolin and quercetin and rutin and curcumin. And I said, wait a minute, this is a tiny little batch about this big. And they were listing 300 milligrams of this and 300 milligrams of that. I said, first of all, there's got to be, like, excuse the expression, a suppository, let alone a little transdermal. Right. And then I said, number two, all of these ingredients are yellow, and yet the patch was white. I said, how could it possibly be? And they had no answer, of course. So they can pull anybody's leg. And as I said, if the marketing is effective, then people will buy them. And unfortunately, with all the economic pressures, they'll go for the cheapest price without realizing that one can say luteolin, and it can be 20% pure, versus luteolin, 100% pure. Well, not 100, 98% is what Algonaut has. But of course, the difference will be tremendous. It costs $500 per kilogram for 98% basically luteolin. Wow. If you go to 20%, it becomes 50. So you can have what's supposed to be luteolin, but it's not pure anymore.
Absolutely. Yeah, no, those are really good call outs because I feel like that's one of the most difficult things as a consumer to figure out is what are you getting? Are you getting what you're actually buying? Right. And how do you know that? So basically we need all to be looking for that certificate.
We should, except that, as I said, it doesn't really mean much within the United States because the FDA